In this chapter 10, the rotation of a rigid object about a fixed axis, we will talk about the rotation of a rigid object. A rigid object is an object that the distance between a pair of points on the object will not change, or simply a rigid object is the object that the shape of the object cannot change. And we talk about the rotation about a fixed axis. So it means that we are talking about the pure rotation. It means that the axis of rotation does not move. So we will consider only the rotation about this fixed axis, like in this figure. Like in this figure, the spinning of the top can be considered as a rotation of a rigid object about fixed axis if this axis of rotation does not move, and the top can be considered as a rigid object. So we will consider the motion of this kind. We first start with the definition of the quantity that we use to describe the rotation. That is, it is the angular position, the angular velocity, and the angular acceleration. This is similar when we talk about the linear motion of a particle. We have to define the position, the displacement, the velocity, and the acceleration of a particle. We then derive the equation of motion for the rotation. And in this chapter we will talk only about the rotation under the constant angular acceleration. This is similar when we talk about the motion of a particle with a constant acceleration, but that in that case it is a linear acceleration, but in this case it is a linear angular acceleration. We then discuss the relation between the angular and the translational quantity. You can see that when we talk about the rotation, and if we look at a point on the object, that point moves around the axis. So we can say that we have the motion of this point. And what is the relation between the angular and the translational quantity of that point? And we will discuss in this section. Also, when there is a motion, like if we say that at any point on the top move allow the axis of rotation, it means that we must have the kinetic energy. But now we call it the rotational kinetic energy because it's involved with the rotation. We next discuss about a quantity which is quite important when we talk about the rotation of a rigid object or a rigid body, that is the moment of inertia. The moment of inertia, we define the moment of inertia in the process of the derivation of the rotational kinetic energy. Moment of inertia is somehow similar to the mass of the object, in the sense that the mass will tell us how hard or how easy to move that object. Similarly, moment of inertia will tell us how hard or how easy to rotate a rigid object. Okay, so if in this point, mass and moment of inertia is similar, but we will see that there are some difference between the concept of mass and moment of inertia. And like when we discussed about the linear motion, we first discussed the kinematic equation, discuss how to describe the motion, and in section 1 to section 3 we talk about the kinematic equations of rotation. In section 6 we will talk about the cause of motion. For the rotation of the rotational motion, the cause of the rotation is a torque. This quantity is similar to the force which is the cause of the linear motion. Okay, so we will talk about the relation. We will talk about the definition of the torque and the relation between the torque and the angular quantity in the rotation. And in section 7 we will talk about the equation of motion, like the second law, the Newton's second law of motion, but this is for the torque. So we will look at the relation of the angular quantity and the net torque. How the torque introduce the angular acceleration into the system. Okay, like in the second law of motion, that how the force introduce the acceleration to the system. Section 8 we will talk about the energy consideration in rotational motion. That is, we use the concept of energy to solve the problem, the rotation problem, like in the linear motion, that we can use the concept of the work energy theorem or the concept of the conservation of energy to solve the to analyze the motion of the particle. And for the last section we will talk about the rolling motion of a rigid object. This is a little bit we introduce a little bit complexity to the system by allowing the object, the axis of the rotation, to move on a straight line. Okay, it means that the direction of the axis remain the same, but the position of the axis may move with a constant speed, and together with the motion of the axis, we also have the rotation of the object. So the combined motion is the rolling motion. And we can use the concept of the rotation of the liquid object to describe this kind of motion. And together with the concept of the rotational energy, we can analyze this motion like we solve the problem of the linear motion of the particle.